Hello everyone, we are Group 4 from Tutorial 1. Today we'll share the VR technologies for the beam visualization in a Hong Kong construction sector. And I'm CTN Scarlett and I will talk about the first half of this presentation, and my group member Larry Tong will introduce her content in the second half of the presentation. Here's our table of contents, and our talks cover 6 parts, including the background, method and device, a hand-on experiment, advantage and limitations, suggestions, and also the conclusions. And first of all, I would like to talk about the background on need for the VR-based beam visualizations. And in the AECO industry, BIM has been widely adopted. Yes, the traditional 2D plans or even the static 3D models fall short. VR with BIM is transformative. It offers an immersive experiment, turning flat drawings to a walkable space. BIM-based system and VR headsets provide enhanced information visualization, which is crucial for the project success in Hong Kong's dense urban project. And after that, I would like to introduce about VR-based beam visualization method and device. VR-based beam lets the stakeholder to explore projects before the construction begins. There are three main components included in VR visualization. First of all, the beam-based tool, including the Autodesk Reference, Tekla, and also the ArchiCAD. And the second one is the data exchange tool, which is to prepare the BIM data. And also VR stimulation package are also needed to, and usually game engines like the Unity or Unreal that convert data into interactive 3D. And for the hardware side, we need a high performance PC plus a VR headset to handle complex model to avoid lagging. And to better understand the operation and the advantages of using the VR visualization for beam modeling, we have tested two platforms. And in the first trials, we used the Oculus Quest 3 to experiment the VR visualization. At the beginning, we felt non-intuitive and spent around 10 minutes to adopt, and some disorientation occurred during our first trial. After getting used to the Oculus Quest 3, we found that the device allow us to viewing the model from all aspects and allow the realistic rendering. And design can be rendered to preview the final look with the detailed design and indoor environment. For the second trials, we try another VR headset, HTC Vive, to visualize a beam model that we inputted, and focusing on clash detection. The experiment was highly immersive and practical. We could physically walk inside the simulation, inspect and address every detail of the design, and instantly identify the potential issues and clash at all scale. More importantly, after the first trial, our adoption was almost immediate. However, we also found that there are some challenges in adopting the VR-based beam. First of all, the high hardware cost and produce entry barriers for the small firms. And secondly, the control method and user interface might take some time for the user to encounter the learning curve. Besides, the VR visualization cannot 100% duplicate the real-world experiment, including the sensations of touching and smelling.
Despite these challenges, VR-based BIM offers many promising applications. In design, it allows for real-time simulation and visualization, making it easier to illustrate complex elements like embedded pipelines and lighting design, hence promoting effective collaboration and communication. For cost estimation, details such as furniture and finishes can be simulated, leading to more accurate bills of quantities. BQ can also automatically update with changes in design. In training and education, VR can replicate various work simulations, including hazardous environments, making it an effective tool for worker training and safety drills. Let's look at a real-world example, the MTR Kutong Station. The overall design of Kutong Station integrates historical and cultural elements with natural landscapes, open spaces, and green corridors. The project team adopted design for manufacture and assembly, DFMA, as well as MIC to minimize on-site work. With the aid of BIM and VR, integration became easier, project quality improved, and safety and complexity were balanced more effectively. The benefits of using VR-based BIM in the construction of Kutong Station are clear. It helps select cost-effective plans, reduces waste, and improves resource allocation. It also enhances understanding of complex designs and spatial relationships, promotes collaboration, and enables instant design adjustments, minimizing miscommunication and enhancing effectiveness. Moreover, VR-based BIM aids in identification of possible dangers. It makes safety management more effective by allowing teams to explore different scenarios virtually and understand spatial constraints. However, over-reliance on VR technology can cause faulty assumptions about safety measures and jeopardize worker safety. Enhanced stakeholder engagement is another highlight of VR-based BIM. Stakeholder engagement is improved through realistic 3D previews, although non-professionals may find the models challenging to interpret. Privacy concerns due to visual data sharing can also be a potential risk. It is believed that VR-based BIM technology can significantly improve project visualization capabilities, allowing better communication among project team members and decision-making, also reducing likelihood of errors. However, these benefits come with increased workload and initial cost. The starting capital can be enormous, and time needed for VR training and model preparation may delay the overall project completion. To maximize the benefits, we suggest focusing on 3 areas. First, interoperability. Developing international standards to ensure efficient communication between BIM and VR systems, which can be very challenging. Second, training and education. Helping personnel adapt through workshops and seminars. Third, legislation and policy. Enacting laws to promote the use of VR BIM in public projects. A robust framework for interoperability is essential. For safety training, VR can accurately replicate high-risk scenarios, allowing participants to gain practical experience without real-world consequences. Integrating real-time data with sensors, Internet of Things devices, and gamification components can further enhance training effectiveness and motivations. Combining VR with traditional techniques enables employees to understand safety principles in theory before practicing them in realistic simulations. Also, improved efficacy of conventional building technologies. In conclusion, Hong Kong's construction industry stands to gain significantly from VR-based BIM, improving decision-making, communication, and early detection of design flaws. However, challenges such as prolonged project times and data leakage must be addressed. To ensure effective project execution, it's important to strike a balance between conventional methods and innovative technologies. Thank you for your attention. Does anyone have any questions?